some of the charts that we can pull and what they mean, and maybe talk about a little bit as we go. So the obligatory little bit about me. I'm a SE here at 7 Signal. I've been here for about 8 years, and I have been designing, installing, troubleshooting, otherwise messing with wireless LANs of one sort or another. Literally since before Wi-Fi. The first networks I installed ran in the 450 megahertz range. So not fast, but good range. Today, like I said, we're going to talk a little bit about, can we see any differences in data rates, both uplink and downlink, sorted by OUI. And our Sapphire Eye product, it monitors data rates over the air. And of course, we really only know what a device is by its OUI in most cases. And then we're going to do a couple little detours and talk a little bit about MCS index and MAC addresses. All right. So, I started out here and I pulled these from 2 different sites. They're both corporate customers. One of them is running Cisco AC APs. The other is running Aruba APs. I want to talk a little bit about what these charts represent. So for non-legacy, 802.11 in AC and AX, the modulation rate and coding scheme is encoded with an index. The higher the index, generally more complex the coding scheme is going to be, and the better your connection. We can look at raw data rates, but we usually look at that MCS value, since when you start looking at the data rates, the number of streams and the channel width begins to play in effect. And something that I thought was very interesting on this one, and we see, by the way, each vertical line is a device. The scale on the left is the percentage of packets downloaded and uploaded at a particular MCS value. So 100 is 100% of the packets we saw from that client were at that MCS value. And generally we see a pattern on these that we want to see. We've got most of the traffic at the very high MCS rates, and it falls off pretty quickly. And there's not a lot of traffic at the lower data rates, more or less. There's a little bump down here, but mostly it's working pretty well. But, I wanted to talk a little bit about MCS 9 and why it is that we don't see a lot of MCS 9 on the network. Is it a case that, we just can't achieve those data rates? And it really isn't. What it comes down to is, if we think back on the MCS table and we look for single and 2-stream radios, we'll see that MCS 9 is not supported on those. There is no data rate that corresponds to that. So naturally, we expect not to see a lot of traffic, a lot of clients at MCS 9. And in fact, all the ones that we see are going to be 3-stream clients here. Those are the only ones that can access that 256 at 5/6 coding. So I'm not sure if that was something everybody realized, but I thought it was an interesting pattern in the data. What do you think, Chris? You see that a lot?
Yeah, it's also dependent on, channel widths and things, but yeah, it definitely gives you an idea of how your devices are performing and which of your, how many high-end devices you actually have in your environment. So you can really see, based on, if you're making decisions about your wireless, what devices are actually consuming the data rates that are available to them.
Yeah. Are you actually getting those data rates that you're paying for, right?
Absolutely.
And then you'll notice the other thing, these, I'm going to look at these by device, and you'll see these are the unknown device. And I've said it's mostly the LA, the locally administered bit set. So when we look at ours, the most common device manufacturer that we see is unknown because that bit is set. And I wanted to talk just a little bit about sort of what that is. And they don't actually officially call them MAC addresses. They've changed the name, and I don't remember what the new name is, but I'll probably always call them MAC addresses. But they really consist of two parts. The first half of it identifies the organization that built the adapter. So for 7-signal on our Ethernet side, our address always begins with B89919. That's our OUI that identifies 7-signal. And then the last half is basically a serial number for that particular radio card. The first part of the OUI, though, contains a little bit more information. A couple of the bits are special. It's not just a serial number. And that low order couple of bits, one of them is going to indicate, is that a unicast or multicast packet? Maybe we'll talk about that some other time, because multicast traffic on Wi-Fi is actually interesting. But the second bit tells whether that MAC address is going to be globally unique, that the OUI actually represents a manufacturer and the manufacturer is keeping the serial number unique for that card, or if it's locally administered. So you can set the MAC address of your card, but you're supposed to flip that, and most drivers enforce it, flip that bit to indicate that it's not necessarily a globally unique MAC. And as I said, we see a lot of those, Apple in particular, but really a lot of other manufacturers now as well, obscure the MAC address. They'll set that locally administered and make it random. And it's a privacy enhancing thing, so that people are not tracking you all over the place by your MAC address. What do you think, Chris?
Yeah, I was gonna say that's most phones these days, I think the newer versions of Android and everything, that's all that comes automatically enabled is the randomized MAC, which is going to give you that LA set MAC address on your phone. Like mine had the option for random MAC, or I can actually use the hard-coded phone MAC. But yeah, once again, another level of security changes as you connect different things. So yeah, you're going to see a lot of things that probably aren't going to be able to be identified very easily in the environment unless you know what that device is.
Yeah, that is a little bit of an unfortunate thing about it. It's great for privacy, but it does sort of make troubleshooting and analyzing what's going on both Ethernet and wireless networks a little more hard, a little more difficult. Awesome. So, we looked at what we saw for those locally administered, probably a lot of Apple devices. On Cisco APs, I went to another customer that happened to be running similar Aruba APs. And really, we see a very, very similar pattern. The thing that I thought was a little interesting on this one is that on the downlink side, we actually don't see the Aruba attempting to use MCS9 to talk to any of the clients, and just a very few or a few uplink packets. And by the way, these are data packets, both up and down. We only look at frames. We only look at the data frames for this. So these exclude any of the management traffic and any of the control traffic. It's purely data frames. Then I moved in, and these, I believe, and Zoom is hiding the top of my.
It's the Intel OUI.
Intel, great. So I pulled Intel. Other than unknown in most networks, that is our most commonly seen adapter. It's got the Intel OUI, and of course the AX 200s and 201s and 210s and all that are super common. They're in most corporate machines now. And we do see a lot more 9s on this. A lot of these are 3-stream adapters, and I didn't actually realize Intel sold a lot, but we do see a lot of these. And then we also see, especially on the downlink side, we're falling all the way back to MCS 0 on these. I'm going to probably not talk in detail about each of these frames. Obviously on some networks, we just don't see any. And by the way, these are 3-stream access points. We would expect to see some. I wanted to, and we'll let you take a look at these when Heather sends these out, but I did want to kind of pull down to this last one, and this is the Microsoft OUI. We find very little difference on the unknowns, the Intels, and the actual Apple broadcasting, but we do see a lot of differences here on the Microsoft OUI, and I believe these are going to be mostly surfaces. And we have a tremendous amount down here at MCS 0. You know, we have some of these devices that are running 100% of the time at MCS 0. This is actually something that a lot of our customers that support corporate devices, whether that's workstations on wheels in hospitals or schools that hand out tablets to the students and need to support those devices, we find that they run these reports and look for specific devices. And of course, we can tell you the MAC addresses. I have it hidden on this. But they will come in and they will look for these devices that are specifically spending a lot of time at low data rates. And these devices, very low data rates, up and down. And we see this a lot, don't we, Chris, where we've got devices that are quite poorly performing.
Yeah, we do. And that's, when you look at like Mobileye and you're able to see, the adapter and driver versions really help when you have both of these together. So you can see if it's a driver issue. But also in, the Sapphire Eye, you can see signal strengths and some other things, but it's really neat to see, the differences between the Intel, the Apple, and the Microsoft's devices and how they perform in the same kind of networks and the different MCSs that you get from them. So, really when you're thinking about corporate choices and devices to support, this is really good information to have to be able to see how these devices will perform in your network or in other networks, and really make some really informed decisions about either how the deployment is configured, and you might have to make some changes to better support those devices. But also having this data, you can see that there may be something else going on specifically related to the device at hand.
Yeah, you have to think something else is going on this one, don't you, Chris?
Absolutely.
Yeah. So, this was interesting. All the zeros, it made me want to dig a little deeper. So instead of displaying MCS values, I came in and I ran this on raw data rates. So you'll see now we're displaying, in this case, here for the 13, it's a 802.11 AC, it's MCS 0, it's a 20 meg wide channel, it is 800 nanosecond guard interval, and if we were to go farther down, these are all cut, we would see that it is a single spatial stream as well. I'm afraid I cut those off a little bit on the charts, but here we're breaking down, and we can see very much the same pattern. But whenever we come down and see, well, what was that MCS 0? And by the way, we lump legacy in with MCS 0. I'm not sure it's the right thing to do, but that's the way we treat it in the displays of MCS rates. So we'll see kind of all of those zeros, and they aren't really an MCS 0. So they're not like here at 14.4. They are actually running at a legacy data rate, 12 megabits, 802.11a. On this network, that is the minimum basic data rate. So that's the rate that we expect the control and the management traffic to travel on the network, and not necessarily the rate that we really expect the data to travel. And we always see a little bit of an attraction for that lowest basic data rate. There's always, even in the data traffic, there's always a little bump there. A lot of devices will fall all the way back to that minimum data rate and spend some time there. But yeah, we can see those handful of devices really having a hard time spending all of their time at 12 megabits. And that, to me, sounds like a driver that's just broken. What do you think, Chris? Broken drivers?
Yeah, there's definitely something going on, I think, on a device level when you see that, because that just doesn't, nothing really adds up when you look at that. So there's something I think that is needed to dig in a little bit deeper on this to figure out what's happening.
Yeah, this would be the perfect opportunity to go maybe do some packet captures on those devices, or try to figure out, are those devices different driver versions, different other hardware differences. And of course, Mobileye is perfect for that. You can install on those devices, and it's gonna tell you about those driver information elements.
Mhm.
One of the other things I thought was really interesting on this, and this comes up a lot in calls when we start looking on this, is, I just said 12 megabits is our minimum basic data rate. So what is up with the 7.2? And this is downlink. So that's the access point, right? It should be obeying for sure. And then on the uplink side, and you can't force the client, a lot of time it is going to go to lower data rates, but it's also got some below 12. So what's the deal? And the deal in that is that minimum basic data rate that we're all used to setting. I think most of the time we're turning off everything below 12 and perhaps higher data rates than that in a lot of cases. So what's with the 7s? What's with the 6s? And that is that those basic data rates really only apply to the legacy data rates. If it's 802.11n, AC, or AX, those MCS indices are still available when you turn off the lower legacy data rates, and the clients will use them. You can turn those off in most access points. There's settings to go in and disable the lower MCS rates, and some people definitely do go in and they'll turn off all of the rates that are BPSK and QBSK and just leave on the QAM data rates. Sometimes try to hot rod the network a little bit. So that is definitely something you can do to eliminate even those, but that is not what affects the control and management traffic, which is really one of the main reasons that we do push those data rates up from their minimum, is to move that control and management traffic to higher data rates and unload some of the network a little bit. Got any thoughts on this one, Chris?
No, Mike, that was a great explanation. And I'm glad you said it. I would be certainly careful about messing with disabling MCS data rates.
I agree. Definitely approach that one with a little caution.
Yeah, I would say if you were doing anything, basic data rates would be the extent, unless you really know what you're doing. I think you could probably negatively impact your environment in more cases than not.
Yeah, although a lot of people say that there are clients that break with it. I've never seen it break, but you definitely approach with caution.
Yeah, for certain.
So, it was a little bit of a short session today, but I hope these were interesting. And I think Eric is going to talk a little bit more about other client data that we can find. But if there's any questions, I think we've got a couple minutes to take those. Don't we, Chris?
Yeah, we got a couple in here. So the first one, Manish was asking, wouldn't locally administered MAC addresses make troubleshooting tougher for us? And yes, it is, because you don't know who the client is unless they're the ones that are complaining. And as I said before, that's part of the reason we have the Mobileye side of things, because once the Mobileye agent's on there, we can tell which device that is. We're able to locate it a little bit easier. And we can track it just by knowing who the user is and their devices that are registered. So that makes it a little bit easier. But unless you know who the device is and they complain, you're not really going to be able to know, because it's obscured for security or privacy of that device. So definitely makes it a lot harder.
Yeah, for sure. If you live in packet captures, it's going to make your life a lot harder.
Absolutely. So then this one's a little bit different, but Andrew asks, when you have scan guns in your environment, don't you want lower data rates enabled? They're not pushing that much traffic. So I've got some thoughts, but I'll let you.
I have some thoughts too. If you have enough coverage, and I know we tend to talk capacity more now than coverage, but scan guns are usually a coverage app. If you've got enough coverage that those guns can run at the higher data rates, then there is not a lot of advantage to leaving the lower data rates on. In fact, by pushing the management and control traffic to those lower data rates because they're going to use those lower data rates, it just pushes up the channel utilization. You can't get crazy, but I would say even in a scan gun, trim those very lowest data rates.
Yeah, because I mean, the faster you get the data on and off the air by using the higher data rates, the less you get energy savings. You're not spending as much time transmitting, so there's a little bit to be gained from turning those off as well. And then also, what other things you're going to be supporting in that environment? If it's strictly just scan guns, if that's all you really need, as long as it's designed for it, that's really the biggest thing is what's the design built for. So you kind of gotta take it with each scenario of how it's actually laid out. And Kit just made a good thing too. Said lower data rates can cause sticky clients, and that's true too because it does travel farther. So if you're trying to keep those clients closer to access points, they're going to continue on and on and on, holding on to those lowest data rates until they absolutely just can't do it anymore. So good point there.
They can,
yeah,
not always.
Not
they
always.
Don't always contribute, but
no,
certain
always and
clients
never.
are.
Yeah. Let's see what else we can see in here. We talked about that one. Okay, so this is the opposite side. What are the advantages of using randomized MACs in wireless connections? And it comes to the security, I think, or privacy. Really. Yeah. So it's being able to track that MAC address of that individual user. A lot of the times you'll see, I mean, it comes standard on most of the devices now, but when you're in public forums and that sort of stuff, I think is really the whole purpose of it is really to kind of anonymize who you are when you're connecting to those, open Wi-Fi's or whatever else you're connecting to out in the world.